Hello everyone. This video tutorial is about the category consistency assessment functionalities in QSAR Toolbox. A chemical category is a list of chemicals with similar physicochemical and structural characteristics, the same bioavailability, and a similar mechanism of interaction with biological macromolecules. In this respect, the category consistency assessment is endpoint specific. The consistency analysis needs to evaluate different aspects of similarity, such as similarity in physicochemical properties, similarity in mechanism of interaction with biological macromolecules considering metabolic activation of chemicals, structural similarity, and so-called ADME similarity. In addition, experimental data from related to the target endpoint toxicological endpoints increase the reliability of the analysis. The assessment of the consistency between the target and the analogues is a very important part of the read-across analysis and can be performed in the QSAR Toolbox. The mandatory prerequisite for assessing the consistency between the chemicals in the list is the definition of a target endpoint, as certain aspects of similarity need to be assessed depending on the endpoint. In the case of a prediction of a toxicological endpoint, we can directly use the category consistency functionality. Following the example in the tutorial read-across prediction considering the metabolic activation of the target chemical, we are going to analyze the consistency between the target chemical and its analogues. In summary, the target chemical is ethyl catcall with CAS number 28930-20-3 and the target endpoint is the LLNAEC3 associated with skin sensitization. The predicted EC3 value of the target chemical is 1.36, and the prediction is based on 4 analogues. The analogues are collected based on abiotic activation of the target chemical leading to the formation of quinone-type oxidation products. Now we can proceed with the evaluation of the consistency of the chemicals. For this purpose, we select the level of the document tree associated with the predicted values, indicated with a gray color, go to the Category Definition module and select the category elements in the Category Consistency section. This is the Category Consistency wizard. We see here the category elements distributed in 5 layers associated with the assessment of different aspects of similarity, such as physicochemical, mechanistic, structural, ADME and experimental data support. Let us now open the information in each of the levels. In the physicochemical similarity layer, we see pre-selected 2D parameters and experimental data on the same physicochemical properties. This means that the results of the selected parameters are needed to consider the similarity of the chemicals. There are buttons to add or remove parameters in case certain parameters should be added or one or more of the pre-selected parameters should be removed. We will keep the default selection of parameters. Now we go to the next level, structural similarity. Again, we see pre-selected profiling schemes from the structure-based profilers that provide information about the presence of the organic functional groups in the analyzed structures and the estimated structural similarity. Keep the selection. Go to the next level, mechanistic similarity. The profilers and simulators relevant to the target endpoint are selected by the system. In our case, the primary group was formed by using the protein binding alert for skin sensitization by OASIS taking into account the abiotic and biotic activation of the target chemical. We want to deselect the other 2 profilers. In general, however, we can keep all the default settings. Go down to the ADME level. Here we see the respective profilers and experimental data associated with different ADME endpoints. If a message appears when opening the section, the user is informed that the ADME profilers are missing and need to be downloaded and installed from the repository first to be displayed here. Please watch the corresponding video tutorial to learn how to install them. The next level is related to the extraction of experimental data from related studies. In our case, the requested experimental data refers to EC3 data. The last level is related to the options controlling how many chemicals should be included in the corresponding report. We will keep the default setting here. Now confirm the selection with OK and wait for the result. The data matrix is automatically filtered so that only the elements associated with the applied category consistency are displayed. Minimize the data gap filling graph. Open the 2D parameters and the levels of the physicochemical properties of the endpoint tree. The result of the applied 2D parameters and the extracted experimental physicochemical data is displayed here. The compared values have no extremes. Now go to the profiling section. According to the ADME profilers, all but the last chemical have the same profiling result of the corresponding ADME profilers. All chemicals have no protein binding alert. Regarding the organic functional group result, we see that the third and fourth analogues have a different result compared to the other chemicals in the list. Please note that the structural similarity used for the purpose of category consistency analysis gives results in a range. The range represents the lowest and highest calculated similarity per chemical compared to the other chemicals in the list. The section with the profiling results of the generated abiotic and biotic products follows. All chemicals produce autoxidation products that are able to bind to the proteins via the Michael addition mechanism. The chemicals are also enzymatically activated, resulting in the same type of mechanistic activation, Michael type addition. In summary, the analogues with CAS numbers 452-86-8 and 488-17-5 are most similar to the target chemical as they have the same organic functional groups and mechanism of interaction with proteins as those identified for the target chemical. Congratulations! Now you are ready to learn more about the individual functionalities in Toolbox and how to use them. Contact QSAR Helpdesk for technical questions. If your question concerns policy or regulatory acceptance of Toolbox results within EU regulations PFECHA's competence, please refer to the ECHA website directly.